in RMK group of college, RMK Engineering College, is right away available here to give a wonderful topic about emerging frontiers in polymer composites. Is going to touch upon many topics, and I think this session is going to be mainly about the sustainability factors, and he has assured to give points related to the um, composite materials manufacturing and related to whatever is related to smart functions and even up to the digital manufacturing. So we are here to invite him formally. Dr. Jayadurga Lakshmi Madam, please take the session and kindly introduce the speaker, madam.
Thank you, sir. Good morning, respected professors, researchers, and all participants of the 6-day online faculty development program organized by Welltech Multitech, Dr. Rangarajan, Dr. Shaguntala, Engineering College, Avadi. We are delighted to welcome Dr. K. Vinod Kumar, Associate Professor in the Department of Mechanical Engineering at RMK Engineering College, Tiruvallur District, Tamil Nadu. Doctor Vinod Kumar earned his PhD in engineering from Anna University and his MTech from Pondicherry University. With more than 15 years of dedicated teaching and research experience, he has consistently inspired students and colleagues alike. His work on natural, sustainable composite materials and additive manufacturing has opened new pathways for greener engineering solutions, and his contributions are reflected in over 30 publications in SCI and Scopus Index journals. Dr. Vinod Kumar has been honored with the Best Faculty Award on 2 occasions, a testament to his passion for teaching and research excellence. Without further ado, I hand over the session to Dr. Vinod Kumar, whose expertise and enthusiasm are sure to make this FDP both insightful and inspiring. Thank you. I welcome you, sir.
Good morning, ma'am. Thank you. Thanks for your nice introduction. I hope my voice is audible.
Yes, sir.
Yes, sir.
You can share your slides, sir. You can, even if you can want, you can show your video also.
My screen is visible.
Yes, sir.
Okay, thank you. So once again, good morning to everyone. So on behalf of RMK Engineering College and RMK Group of Institution, because I worked in both RMK CET and RMK Engineering College, so I'm mentioning that RMK Group of Institutions. So once again, on behalf of all, I thank the Welltech Multitech management, principal, head of the department, and the coordinators and co-coordinators and my fellow faculty members for given such a wonderful opportunity to given such a wonderful topic with emerging frontiers in polymer composites and sustainable materials, smart functions and digital manufacturing. So in title itself, it shows that it's a emerging area. So I will not say that I will cover everything, but I will touch on all the areas where the basics needs are required. At the same time, so I worked in some of the major area, majorly in polymer composites, because from 2014 onwards, I'm working on polymer composites in both thermoset and thermoplastics. And now I'm recently taking care of in my institution composite material, Center for Composite Material, and as well as I'm taking care of digital manufacturing also. So both I will associate it with this specific domain. So I'm having a basic knowledge and some technical knowledge on those areas. So first of all, here, what is composite material? I hope that most of them here, faculty members and researchers, so have the wide area about and very knowledge about in the recent trends of composite materials. But now the trend is changed. What we started as a what means we means I started as a composite material just with the GFRP, and then we mix it with some natural fillers we get, because as a private institution we will not have that much of the research facilities to do the some fruitful outcome, because for us outcome is publication. So I hope all agree first of all. But after involving into the so many of research meeting and discussion with collaborate with so many of eminent peoples. So, and then recently I received a 3.5 lakhs funding for conducting of Atal FDP. So through that we collaborated with so many of eminent people. Those are working in the industry 4.0 to industry 5.0 areas. So only I mentioned the title about digital manufacturing. Hereafter, conventional manufacturing process or conventional machining process will not give some fruitful output. I'm not saying that totally we will wipe out all the conventional method. It will be there, but even though now trend is changing that we need to suitable and then sustainable manufacturing methodology is important. Even though our polluted, most of them we polluted, that we are also one of the part among that. We our earth or something, our TPC level is very very high. I hope all agree. So I mentioned here. So now what are the composite material in recent technologies? We speak about mostly in additive manufacturing and sustainable manufacturing. Now one term is very enriching and catchy to wherever we go, wherever we apply some funding. What is the word will come is artificial intelligence. AI will play the major role. Again, what as a mechanical engineer, as a materialist man, what I could say this, AI is not belongs to only computer science or other IT relevant or other departments. AI is a common domain. From that we can able to do, because artificial intelligence we can, sorry, okay, fine. So from the artificial intelligence will collaborate with any of the things are product based things are required. Even though I'm working in the PLM domain, that is product lifecycle management. So we have two tools are we are using. One is Creo, another one is Windchill. For Creo is for modeling, and then for Windchill we are using for the PLM management. So for that now, if you mechanical engineers want to survey on those areas, so they need to enrich their knowledge on to we have to cross the boundary to learn something programming learned. Because even though we completed programming in Python and as well as we enter into the deep learning techniques, but it is initially it's very struggle to learn those things. But once you learn and once you plan to write some research article, you could understand that what is artificial intelligence will play major role in mechanical engineering terms. Because everyone nowadays is speaking about digital twin, digital thread. Those things are where going to sustain is in industry 5.0 and as well as in the mechanical oriented companies. So only I represent here additive manufacturing, sustainable manufacture, and then artificial intelligence. Artificial intelligence will counterpart is called as machine learning. Machine learning is not separate; it is inbuilt with the artificial intelligence. Now all are thinking about that. How far there are different type of AIs are there. Okay, genetic, general AI, and then genetic AI. Now we are going to use as a synthetic. So when synthetic AI will come, then major role will taken care by the application oriented softwares. So and then here we have the manufacturing of smart polymers. So initially we will do solvent and pre-process technique and then processing, and then we will get properties of those things and morphology. From that, what are the output we will get? Morphology, size, and composition and structures. So these are the major things we will do. Okay. Next, initially, one of the main application is in digital manufacturing is in current scenario is 3D printing. That is called as additive manufacturing. Additive manufacturing is not introduced now. So it's long day. It is surveying in the market. So that 3D printing additive manufacturing is used because of offers unmatched of design freedom. That is the most important, because when we go for a conventional methodology, we couldn't be able to do some complex structure oriented products, and based on the comfortable or constrained space limit. But and when the 3D printings are sustained in the market, it transform the most of the areas. And then the 3D printing transform the polymer composites from static material into a digitally designed smart and sustainable structure. Mostly where our polymer composites are taken care is that is used for a static applications, that is structural oriented. When we undergo the polymer into dynamic application, the market that the material will not sustain that much. So here, if we start with the concept of industry revolutions in subsequent changes, in 70s, 50 to 1850s, it takes about water and coal, steam. There, what is a major role is iron steel will come. After the 1850s, electricity, refrigerator, which is a major role taken by electricity. And 90s, 50s to 2000, that is 2K, we get electronics and the automotive production, that is industry 3.0. And industry 4.0, everyone know that what is the new technologies introduced is material science and 3D printing, and then quantum computing in that areas. But mostly our central government is spending nowadays is for another one is material science, because when we applying or when we approaching any people from uh, CSR or ISRO, DRDO scientists, those peoples are, and most from the we have international collaboration also. So they are saying that, sir, we are private institution. In what way we get funding proposal from the central government or some collaborated with other peoples? You touch the novelty of the work with recent trends and what is emerging areas. So they are speaking about in if you are thermal, go to with the green hydrogen storage, how to convert, what are the types of batteries you can able to remodify, how to energize the batteries, because now the Tata is going to introduce to Velur nearly 100,000 crores for implementing EV vehicles. Like that, so many of them going to introduce EV. And all the companies are nowadays is planning to switch over to the IC engines to EV vehicle, both commodities vehicles and as well as our transport other etc whatever vehicles are available nowadays is all are converting into the another. So only here in other China and other US country are discuss about the how to convert the train system to the hyperloop transport systems. That is, we are going, they are thinking about hyperloop. Okay, because within a shortest time how to reach without have any of energy, how to get a high energy methods. So only we are speaking about initially nanotechnology, AI, all are will come, but how far application orientally it will improve, that is most important. So in my shortest experience in these areas, so we can say that on it is sustainable on demand productions compared to the traditional methods, because wherever we go we speak about 3D printing, because nowadays is the MHRD or central governments are implementing more funding about that in a drone based, agriculture based, hydrogen storage, battery. And then now currently they are thinking about IoT devices, Internet of Things devices. So that so far in India, none of them making chip. So in IIT Madras, they are having one small type of SMT machine, that is surface mount technologies. So and initially all are called as whole methodology, but now they are moving into surface mount SMT. In our institute also, our management spent nearly 1.2 course for implementing the chip designs and then circuit boards, electronic based things are going to make in our institute itself. our management spent, and then we opened that SMT lab in our institute. So that much of the trending and then conventional things are most important, because nowadays the spaces are important, storage is important, and then how far we can able to optimally use the all the resources. So those things are important in the conventional and as well as modern technologies. So wherever we go in the additive manufacturing is start from the layman parts to advanced level technologies. It will go for aerospace, and as well as it is go for yes, ordinary shoe making companies, because all are using of customized products. So when you go for a shoe, so that is the most implementally, because all the like foot sizes are not same. So for that they are making that customized shoes are nowadays is in trend. And as well as in Bangalore, one of the post office is made in by using of 3D printing. So now all are thinking about in how far they are utilizing the advanced facilities or trending areas or transformation, digital transformation technologies to implement easily. And then it is increasing critical for a modern engineering, manufacturing, and as well as education, because we are in the teaching domain, in teaching fraternity. So in this teaching fraternity, we have to make the students to listen our classes. So for that we made some innovative technologies, that is innovative pedagogies. So there are so many pedagogies technologies are there. So in that innovative teaching methodology is most important. So when initially if we take for example thermal, if we teach in IC engines, they will get little bore and then they may be sick, because this Gen Z will not will listen that much of attentions. So for them we give projects, mini projects, and then unit basis we are giving some project to make some prototype, design some prototype by using of because we have nearly 6 3D printing in our institute. So that by using of this equipments, you print the machines with a prototype, and then we describing that how it's work. Like we students are making one IC engines, and then students are made some laptop portable, how to keep a portable stand, and then thermo applications, and then as a mechanics of machines, I'm handling mechanics of machines. So we are giving so many of mechanisms to them to create by using of 3D printing, and then we have some laser cutters are available, and then we have CNC router. By using of those things, how to make to manufacturing the product. So this these are the things we are implementing to our students to engage, and then learning them to do something novelty, and then what is the subject, how far we are using those things. So by the way, the 3D printing will play the major role in that. So what are the characters in that, what are the advantages, or what way additive manufacturing will give the freedoms, the applications. So first what we think is design freedom, because initially for example I did in my UG project in Tiruchipil. So my project is belongs to make a fixtures for elbow machining. So initially we started with the elbow machining, after that we went to so many of advanced level of analysis and other things. But we cannot able to machine, or we cannot able to make a thread in that elbows in our conventional lathe. So for that, we prepared some fixture. By using our fixtures, we are doing something, and then that fixtures will do some elbow internal thread or external thread. So, but after introducing this type of additive manufacturing, so we can able to say that yeah, geometry is no longer the boss, because initially there is some constraints is there, geometry is there. We should know that what is the surface, what is the things are you should prepare. None of the things we should we have to think about the geometry or any textures or what type of design it is. And then another one beauty is we can able to by using of another one of things is called as 3D scanner. So by using of another one renovation, we are doing some recreations of our product, reverse engineering. So by using of our 3D scanners, we can able to easily catch the diagrams and then complex structures, and then it will give some profile about in another one STL file. After that, we can able to print. So like this, a complex and internal channels, and then lattice, that is most important. So that also we tried one of the uh, research work in that lattice and graded structures, because how lattice structures will play the, in what way that lattice will play the important role in the physical properties of the materials. So and then impossible with molding and machining. So those things are rectified, and then our this will enables the lightweight, because recently our students are participated with the SIH student, that is SIH from MHRD. In that, one of the problem is to prepare a simplified simplified things, that is for sports equipment. In that we customize the design, and then we analyzed, and then we printed, that is given high strength and the composite metals. So what is the way it is using, that is the image I hope that you can see. So this image is called as aerospace brackets with a lattice core alone. Okay, so nearly 30 to 60% of weight reduction is happened. After that, another one important factor is called as material efficiency and sustainability. There are nearly zero waste of material added only when where needed. But another one is there, when we having more number of curvature or textures, in if we need support, so in that area, yeah, we have to waste the materials. But when compared to the conventional materials, that time we are material is very less, then it is also suitable, and then it supports the bio-based polymers, and then recycled fibers, lower tooling, and then lower carbon foot. Another one is, you maybe see here one of the nylon fixture. I hope this is nylon fixture. So in that nylon fixtures, we they are prepared one here. So in our lab also we prepared one nearly of 50 diameter with a length of 35. We prepared one fixtures for preparing of some movable objects fixtures, because we are doing some mold preparations. So for that we prepared nylon based 3D printers. So based on that we prepared some one fixture for die, and another one is for a we given some work to my students to do some old arms coupling in kinematics machinery. So they prepared this type of fixtures, and then we assembled, and it's working very smoothly like metals. Okay, after that, rapid prototyping is another one important characteristics. Faster innovations in idea, prototypes, and then test, and in days, not in month. Fast iterations, composite layers, and fiber orientation. I hope most of them, if you are working in polymer composites, initially for your publications or due to some another novelty of works, they will do so many of orientations. Okay, so one of my fellow colleague, he did his whole research in orientation alone. So they change the layup orientation 30 60 30 60, and then 30 30 30 90 30 like that, both based on the fiber orientation, what way it will help the mechanical characterization and as well as material characterization also. Now, what is the another emerging area in 3D printing, and most of the researchers are doing? So they also changing the printing direction. So either there are different type of, we also tried, we submitted two papers in that area. What is based on the orientation, how it changes, and then based on the texture, because it is when it is honeycomb, when it is square based, when it is a rectangle based, how far it is implement. So in that you maybe see that here this is a called as a cycle bicycle frames. So they are making as a easily as a fast innovations ideas in rapid prototypes. Next one is toolless manufacturing. So it is goodbye to the expensive molds. Why is, I hope that you can see the two images. Nowadays, if you get this type of ankles, or when you get any pain on any pain in your hand, or for that customized, and then it is recyclably, one of the sticks are given nowadays. Initially it is more expensive, now it is changed into another things. And what is the another major parameters or properties will play in by the additive manufacturing is smart and functional integrations. It is embedded with a sensor, conducting parts, fiber directly structure plus sensing is equal to smart composites. When we speaking about if we are doing any of them doing in the area research area or going to do any research, if you think about smart composites, that will play the major role. You will get special attention because I hope this is the image for that sensing of boats in aerospaces. What are the things are, because it's a very high budget and then very costliest vehicle. So nowadays is most of them came to know that in news is within a 10 days you maybe say that there is so many flights are cancelled due to some malfunctioning other things. So and then because there is a called as a continuous monitoring process are required because it's a very major causes. I hope everyone visited ISRO and then visited launch vehicles because fortunately we visited so many times ISRO because our professors are very collaborated with the ISRO scientists in Sriharikota. So fortunately, I visited PLSAV 4 and PSAV 4. That time we visited launch and we nearly close to that. And then they keeping some outer layer of in the every rockets. They are keeping some RDX launches. We don't know why they are keeping RDX in the outer boundary of the sealed RDX means. But after that only they told that human values are more important than missionaries. So like this, all the products are need to be monitored. So for that, those who are planning to do research, they may thinking about structural plus sensing that will give a major novelty area and as well as application oriented area. So initially, my guru always says that don't blindly do any experimental works. Okay, what your application, where your application going to implement, in what way it will contribute to the social causes. So that is most important. So if you know the application point of view, based on the application point of view, if you find any materials, then it will give the major impact. Next, you have that another one. So all of them speaking about a digital thing, because whenever we approach people in any corporate people, they will come and they will speak about only digital twin, and then they are speaking about industry 4.0 IoT, because in our college we have more number of center of excellence. So in that center of excellence, we have recently in last Tuesday they opened IoTD. IoTD means Internet of Things in Design Engineering. So it is inclusive of all the department. It is purely not only belongs to one department. It belongs to the all the department. In civil, this will come, and in mechanical PLM will come. EC IoT will come, and in CSC they are taking care of SAP will come. So all the departments are nowadays as all the IT sector and as well as core engineering department will integrated the all the domains in one specific initially, and then as I am taking care of AICT also. So in that nowadays if we are going to apply any department, inter collaboration department is preferably they are welcome. So only we are speaking about industry, digital manufacturing and industry 4.0 ready, because whatever product coming into the market, that will not sustain more than a month. At what level, in what are the things, whatever product it may become. Okay, some of the rarest products are sustained, like our Rolls Royals, like that. Any other products are even though sustained. But if you're taking that, the novelty and digitalizing of products will taking care of most of the things. Whether today news you maybe checked that one recently, BMW and other cars are overtaken by one of the, yeah, one of the car company. I hope anyone answer for this.
Audience, please interact. Anyone of the person here, student or faculty, whoever is there, please interact.
Okay, no problem. So one car is they are nearly of 90 lakhs, but even though it is sold more than BMW, then Audi and Benz, because initially in commercial of Indian vehicles or Indian transport systems, BMW and Benz are will taking care of major role, but that is overtaken by today one company. I hope that also you search, because nowadays is that will play the major role. 90 around 90 lakhs around come to its own core, even though it is the most booked recently. And here if you see the digital manufacturing, CAD and simulation, and after the simulation it's go for the print. After that we get a data feedback loop is there. So this is will come. Now what is now going to implement is perfect digital twins. I hope everyone seeing some Hollywood movies. So when spider that is Iron Man glass, that is called as digital twin or digital thread. Okay, that is initially introduced the creation of creativity of humans. So that glass is called as digital twin. In Microsoft they will use as a HoloLens. HoloLens is there. So and now all the companies are nowadays is thinking about to create digital twins, AI driven optimization. In our college we created our management spent nearly of 1.2 core for the AR/VR lab. So in AR/VR lab, our students, even though our mechanical engineering students, they are preparing some projects to make the physically appearance of products. By using of some of the softwares which can easily accessible by the other software engineering peoples. So even though we also, as a mechanical engineering, I tried the so many other softwares like a Blender. So this type of Blender will use some Industry 4.0, because when we approaching or when we proposed any proposal, we are not giving nowadays is this will happen in write up. So what we are planning to do and we did from past this 6 months, by using of some Blender applications and some software applications, we are giving that exactly how it works in animation. Industry 4.0 and Industry 5.0, machine to machine is given by Industry 4.0, and Industry 5.0 will going to think that how if the any maintenance or any protections are required, automatically without of knowing anything it will clear or it will give options. So when we approached Infosys, because we are having some lab along with Infosys, so in cyber based things. So in that Infosys, they are giving that some project that how for the mechanical only they are working from some core company. So in that how automatically protectable, in what way that predictions will help to prevent the damage or shut down by the machines. For example, we approach they given one problem. So if I want to be analyze the any engine or any machines without of after the problem, that machines will say that by integration of some IoT, it will say that what are the solutions for that, and what, for the solution, what are the success ratios are happening. One of our students from the IT department, they created for one solutions for that, and then it is proposed, is placed around more than uh, 35 lakhs per annum in that specific domain. Okay, so that the perfect match will come to the digital twins or digital thread to the AI driven optimization. So additive manufacturing is not only making the product or making some complex structure of the product. Additive manufacturing is a one of the tool to give some output. Okay, but it is integrated with so many of things. Nowadays, most of them is working in what are the extruders we can able to make, because we also don't have the extruder. We approached Mamila Ravi Shankar. I hope those are working in additive manufacturing. He is a well renowned person in this southern region. Mamila Ravi Shankar, head of the department in IIT Tirupati. So he given some extruder idea, so don't stick on with extruder. You maybe go with a customized optimized extruder. Don't stick on with only metal, because metal is more costly. In around Chennai, only few of them having metal, so it's more costly. So we also approached in IIT Madras also. It's more costly. We cannot able to afford for 1 hour charges for as a private engineering colleges if you are not getting funding. So we applied ISRO respond also. In that ISRO respond, we quoted that we request the sponsored amount is, our quotation is 45 lakhs for fabricating, not in a many machine. We are not requesting any machine. We requested for fabrication alone 25 lakhs in Bangalore. So they say, we sent that these are the samples we have to print in metal additive. So you just give the quotation. So they conveyed us. They given some quote nearly 25 lakhs for printing alone, and then 10 lakhs for testing. So other consumers for our equipments, small equipments for miniature UTM and microstructural images. For that we quoted that nearly 45 lakhs it will come. So up to the second level, we went for ISRO response. Third, up to 3 level we crossed. After that, if you are depend upon another company or another organization, how you can give your own product like this, they will say it and then they will reject it. So digital manufacturing will play the vital role in current scenario. So after that, another one area. So recently we are working in this area. We are collaborated with Mr. Ravi Shankar in NIT Orangal. So he given some of the idea and then working in this. So this is from coating, bio implants coating nowadays. So dental applications in human body, most of the things are initially it is taken by one simple rod or some valves are there, but now all the things are working. So we spoke about some Bangalore, uh, some innovations tech lab. They are doing some bioprinting. Bioprinting means tissue cultures, like tissue cultures. So you maybe see here. So they are replacing, this is another one. This one is normally implemented, but after that it will give some side effect. Now most of them researchers, and Mamila Ravishankar sir itself, he is doing some work in this area, and then he published more journal in that area also. You maybe see here it is polished and then it is finally in color. What are the wave of the corrosions are there here? What are the spaces will happen when we use oscillation integrations, bio integrations are both analyzed. How it is, this is given by the Ravi Shankar sir applications we taken, and then all the things are we are using biobonding. So everyone speaking about additive manufacturing is long milestone. So it is initially is started with a photo sculpture. After that, in 1890, it will come as a topography, and 1920 it is material deposition. And after that, it will now first patent is filed on only on 1968. I hope you all cross that. As a private engineering college nowadays is every engineering college have to publish paper, every engineering college to engineering faculties have to publish some patent. So patent is important when we have a small novelty. Don't think these are the things are not pattern. For the best example is our cricket stump is the one of the best example of a pattern. So because of this stump, cricket stump is earning nearly 40 lakhs per match. So like this, maybe one of the small sensor with the intact, it is an hostile. Only one pattern is published and then granted in more country is called as stump, our cricket stump. So like this, don't think that it will not granted. Okay, so don't think it is not published. It is not having that much of novelty. If you are doing small amount of quantity or small amount of novelty in this work, you will publish extraordinary work. So nearly we published 8 patents under our guru and me, and then we granted with nearly 4 patents are granted under us. We based on that small applications due to the private engineering college. So we are manufacturing for our lab equipment in our own engineering college itself. So we created some digital impact testing machine. We created some composite preparation centers. So like this, for that we applied patent, and then it is granted also. Initially, we are made 2 patent is one is for composite material, one patent is granted, another patent is granted under that ABS anti braking systems. For that also one of the patent is granted. Only two along with our students. That is the major important. So our inventors is 4. One is my and then my guru. After that, 2 students are there. Those who are working in that area, they will also support us. So we give some credit to our student also. In private engineering colleges, we are getting that our students are working in small work, and then we are doing some publication also with a student name. And now we can able sir. So in 2014 only first additive manufacturing parts on fight. Okay, that is major things are that he is a man mostly in front of that company. You maybe see background. Most of the things are nowadays is using. It is a process of joining materials to make a parts or objects from 3D model data, usually upon layers, and opposed to subtractive manufacturing and formative of manufacturing methodologies. Next, applications. So I hope that you maybe see here. So where we can able to introduce or where we can able to look. So don't think that our central government is funded nearly more. Recently, we submitted one of the funding proposal also in motor vehicles. You maybe see here. So what are the funding applications are? What are the additive manufacturing applications are there? Major contributions for consumer product and electronics. That is 21%, because everyone crossed the COVID period. During the time, ventilators, and then others. So now the medical field is running not only running with only medical oriented medical products also important. Whether you people are nowadays is taking BP or any other sugar testing or syringe. If you take the syringe itself, that syringe itself it's take of more number of complex, and then how much of doses, that also patented. So we are thinking about that pattern is that also pattern. So that so all the areas are nowadays is wide ranges. You see that most of the percentages are below 15. If you take motor vehicles are 18.6, so only governments are nowadays is planning to do more number of parts in additive manufacturing due to the shape curvature. We will speak about uh, flow analysis, textures, how far aerodynamics will play that initially. So those things are most important. So after that, all the nowadays is private sectors are planning to create the own companies. We are near to the Kumuripundi. In Kumuripundi itself, around that is near to the Tada, we have more number of companies are introducing nowadays. Whether because we have Isuzu, after the Isuzu, another company Kia Motors. So and then near to our college itself, that our Indian product. I hope everyone know tube company that is very famous. Company is producing EV vehicle for the three wheelers. So now around our campus or around our road, we are seeing that more number of companies, more number of vehicles are roaming with heavy loads and testing. They are not doing any crash tests, or they are doing some dynamic balancing tests. I hope company name.
So there is a company near Oragadam for central government testing facilities. Are you referring to that company, sir?
No, sir. Actually, one of the in Ambattur, it is a famous company only. I could not able to remember that company because we visit TI cycles. Sorry, TI cycles along with Murugappa Group. They are created one of the company near. They are manufacturing one 3V vehicles, sir. EV vehicles. They are doing some test and trial along with surface area of road. In around Pennagaram, around some only one testing center is alone in India, in Chennai, South Zone. So they are doing Magendra only having that testing facilities for the not for the commercial vehicles, for the our day-to-day car other things of transport lives. So that application of additive manufacturing. So anyone is planning to do some research area, and then MHRD giving more funding, and then we applied MSME funding also. So one of our professor from Muthukrishnan, associate professor, got along with our students on 15 lakhs fund from MSME scheme. So nearly we got 1.5 for a mechanical. They given 15 lakhs for drone development systems. And medical identical, again medical and dental will also taken care by the additive applications. And after that you maybe see that orthopedic surgery, dental surgeries, and plastic surgery, and cardiovascular surgery, general surgery. So most of the things are nowadays is taken by care by the additive manufacturing oriented. I already told that constructions, additive manufacturing is not only doing for only mechanical. So when our EC students will preparing some IoT devices, for that our 3D printing or mechanical oriented people will helping for the a collaborative support. For that, one of the drone systems are prepared for surveillance for the civil people. So for that, mechanical students are given some 3D model for the drone development, because our student got more pricing for drone development systems for payload. So nearly our students prepared 3 kg and then 3 kg to up to 10 kg of payload can able to lift with the rest weight of 1.35 kg drones can able to lift. So that much of the stability, having that much of drones, and with an lattice structures also they prepared. How far that payload equipments are there, how to change the payload geometrical structure. So that type of the things will give the applications of additive manufacturing. This is a general one as per the ASTM standard. So whatever we are doing, this is additive manufacturing, because whenever we are doing, when you're writing some paper, you should mention about what are the manufacturing method. Initially we worked with say a polymer, because due to that facilities we cannot have that much of facilities, we prepared the glass polymer composites in hand layup method, After that, we created some facilities. Then we move to the compression, molding or compression. Then next we go for hard pressing. After that, we evolve into vacuum bag molding. So up to that only we can able to do. Now all the things are now filament is it's very difficult to create it, but when you're having a processed material, polymers can able to do, metal can able to do, and ceramics. First one, polymer can able to affordable. That only I can able to say that metal and ceramics are more costly materials. Costly means costly manufacturing materials are, because we couldn't be able to purchase as a private engineering college, because around 3.3 crore will for metal, and more it's more higher. Ceramic is still more higher. So powder is initially we have the filament, and in that filament we are using in our equipment lab. We have nearly three. We have high temperature polymer printing also available, and as well as up to 250 is commercially available. That we have more. In a high pet we have that peak materials, so up to 450 we can able to print. When we are having working with any medical applications or high strength, then we go for a peak material. Peak material will give the major applications. We give more consultancies in peak, that because it's take much more costly, because 1 kg filament itself it's go for around 45,000. Now it's more costly. I'm speaking about 3 years before. After, due to the material costly, we will not touch that peak material. But when we get consultancy work, we are printing, because our printing time itself it will take nearly 16 hours, sometime 24 hours, more than 48 hours also printed. Because one of the company from the dental things, they dental and as well as medical field, they ask to print one jaw. So nearly that will be taken for 28 hours, I hope. So for that, because when compared to the company, our organization will not think about the money. So we printed with a peak material, and then nominal charge only we charge it for it, because we have to move something. It's happening in that material. So I hope that everyone know that first one, determination of object, and then we should go with create the design, the basic. After that, it will generate the G code. After the generate of G code, nowadays is no need of any wired cable to connectivity. Nowadays is wireless communication also, like printer. So wireless printer also come, so we can able to transfer the filament. So as a private engineering college or this type of the things, we have to customize the 3D printers, because one of my student is prepared one 3D printing by multi-extruder. Multi-extruder means I hope you are all aware about. So by the same time, it is not print same material, but layup. We can, that also we did one research. One year in one layer we can able to print with the PLA. Another layer we are print with PG, like this. How far it will give a compactability factor. So those things are we are analyzed. And then we have printboard is we having with a multi-nozzle only. So in multi-nozzle we can able to print it. But after this, our student prepared, our student created some 3D printing that will is mostly suitable and utilized by the people. Is more usage is more, because when we speak about that the commercially available printer, we will see that we will not utilize it properly. We will not utilize means we are thinking about if you happen anything, how to service those things. But our students created 3 printers, that is wherever we like and whatever students will like, they are wish to change, they wish to do something. For example, in one layer, because aesthetics looks is most important. So we prepared initially our campus in 3D printing alone. So our campus blocks, how our campus looks like that we prepared. After that, another one is one of the student is prepared as a one drone with a different color of textures. Flywheels are how that motors based coverages in different colors. Same thing is happened in what the students is optimizedly made that one is. For a certain it is, for example, it is a 20 thickness. So for 10 thickness, they will put one color, and then one color for another 10 for another colors. So because when we having that much of things, the filament have to print. Initially, we faced a lot of things, because when the filament or extruder want to print, that much of a time is taken to print. So when the nozzle are 1.5, 1.75 mm is our filament sizes. So our nozzle is nearly around come to the 0.75 we will are printing. So our nozzle want to heat, we given some additional support to both our board and as well as nozzle. So like this, the students are interested to create so many of the works. Only one thing, we have to support the students to create, and some from this we get mostly nearly 10 failures. After the 10 failures only we got one fruitful outcome of this one. Next, this is a general procedure to make a filament. Okay, feedstock, liquid or powder, whatever it may be. So it's come to the first feedstock from physical type. Now it's changed into automatic also. And after that, additive manufacturing, there are different type of principles are available. Polymerization, binder. Initially, it's go with only polymerization for initial process. Now binder and then atomization. And after that, now thinking about melting and solidification for proper homogeneous, and we give the homogeneous properties. After that, joining and all we will not think about directly, but majorly we go with the powder as a structural application, other things. When we go for a liquid base, then it is go for bioprinting parts and other things are we are going to with that. After that, what are the feedstock type? Now we are working with this only. So we have to make some customized additive extruder. That is most important, because now researchers are, one of my PhD students is working in that area only. We are going to inbuilt or based on the compactability factor, we are merging with two more materials, and then based on the various of percentage we are mixing, because initially it takes more costly when we give to, because when we speak about any industry to make filament to give, because I need some PLA with some natural composites, natural fillers, because I work more in natural fillers and natural fibers. So I give some combination for that. For one composition, 1% alone, they are requesting us to give minimum of 2 kg or 5 kg. Then only we will consider for order. So if I take that much of amount, for that itself it is 25,000. They are requesting us. They will not give material. I have to give material. I have to give feedstock, all the things. But for making of extruder pellets. For pellets itself, it will give more charges, or filament like this they are charging. So for that, we are planning to prepare something to customize. After that, what are the additive manufacturing process? So that is, initially it start with VAT photopolymerization, binder jetting, mostly now binder jetting, and then material. So all now thinking about powder bed fusions. So FDM, stereolithography, like this, they are mostly using direct energy depositions based on the textures, and metal extrusion. Metal extrusions are, we will go with when we have some specific applications or any grain boundaries, and then sheet laminations. So then it is most important. Next, I hope 2 applications. This, if you are going to propose any proposals, you work on these 2 areas. It is not highly like rocket launch. So we go with metal additive manufacturing, aerospace and medical. You maybe see here that is a shuffled walls. They are using very smallest parts. They are using in this. We are in here. It's a stud, like stud walls. Nowadays, everyone using angios and other things. For that, you maybe see here how far it is optimizedly making that one. It is one of the microstructure, and this one is one of the major things are using of metal additive things. Next, biomaterials. Biomaterials also, if you having any idea about biomaterial, so it is synthetic material used for replacing or restore the functions of body tissue. I hope that due to some reason I will not show that. One of my cousin is working in medical area. My brother-in-law met accident. Due to that, they prepared some bio tissue. For that, initially they will put some called as collagen. collagen like that they will put, and then it will not change. But after that, some said that we have some collagen to change into some bio tissue. It will look like a skin, but it's not exactly 100% skin. It will show like a skin when he made a major accident. So for that, so they made as a one of the tissue by using of bioprinting, and then it is fixed, and then it is comfortably. So far, he is comfortable, and then that tissue will continuous and intermediate and contact with the body fluids and give something. So first foremost, biomaterial must be biocompactable. That is most important, because we cannot be able to add A plus B, it will give C. Or otherwise, whatever you like, A plus X is not equal. So we should see that it will give a biocompactability. Biocompactability is, so initially we did some more work on that. Whatever we give, it will, what is polymer major role is, whatever you give to the polymer will take. But it is chemically bonded. That is called as biocompactability. Major things I will say. So initially, mostly we will publish some journal. What we'll do means they will find some natural fiber. They will started with a discontinuous fiber. So they will chop the fiber, and then they will mix with the epoxy, and then they will make some ASTM standard tensile or flexural or impact or whatever mechanical properties like they will do, and then they will get. But when going to test the material, what it will give, it will give the properties of matrix, but it will not give the properties of filament. The filament will not give the enhancement of that. One of the professor from he is no more RK sir, we call as RK sir. RK sir will say that whatever using natural polymer composites, that are all ambak. It will not going to replace. But after that, he agree that when we having the biocompactability, it will sustain, then it will give impact. Just if you add with the hand layup method. For that also they told about, don't go with hand layup. Hand layup also will not give something. You can publish a journal, that's all. But that also, it's not having any logic to using the hand layup method. How can homogeneously the matrix and the particles are compactably added? Or otherwise, how far it is give some effectiveness in the materials. So all should think that for that we are using some ultrasonics. We purchased something for that. So for matrix, and then we created some ultrasonics to how chemically want to give some reactions. So those things are give major effect. Initially we started with the one of the work is called as one conch filler. That is one fillers are there. So we crushed and then we mixed it with the epoxy. It will give some impact due to the ceramic materials. But when we using of ultrasonics or some other sonics things to mix to chemically, then the properties are increased. Nearly 200% impact is given. That is called as biocompactability in that materials, most important. Additionally, it should be non-toxic, because some of the time we blindly cannot able to immerse or cannot able to add the materials. Whether when it is chemically reacted, it will give more side effects some of the time. Okay, because when we using hand layup method, epoxy is something within a hand roller itself. When it is heated, our whole block will get smell, because that much of the things may be happen. That should not happen. But its requirement is eliminate of many engineering materials that are available. Next is biomaterial should possess adequate physical and mechanical properties. So whatever things will come, because all the mechanical engineering students should know about material. Because without of knowing of material, they will not play the major role in various areas. Materials are most important. So that material properties will serve the augmentations and the replacement of bone tissues. So recently we approached some Savita colleges, Savita Dental. So they are preparing some of the scaffolds and then some dental applications. So for that, they are saying that hereafter no need of making of any metal oriented. if we make biocompatible polymer equipment or polymer product, or that will give that no need of replacing something, it will keep behave like a bone. So they are preparing like this. How for biotism? Because we approached them, they told that sir, no need of metal, sir. Metal will at one day it will give problem. We can able to replace those things. So for that they are going with a biocompatible product with like a tissue or any bone or dental oriented things. So that will behave like a same what human beings have there naturally, at least 90% or 70%. Then it will can able to replace multiple time, then it will give you a fruitful outcome. So biometal should be amenable to be formed or machined into the different shape, have relatively low cost and readily available on oriented areas. Next, so these are the areas in journal of that is handbook of materials for medical devices. You maybe see that all the here things are we can able to change. And one of our first year students, I hope this is a image, our first year students prepared one uh, things is for agro manufacturing. This is under how to reusable peppers, or by using of how to improve the easily growable with fast growing with a natural fillers. That is we published journal also in one Springer journal. Our first along with the I'm not having that much of knowledge on this area, so one of our chemistry professors helped for us. So by using of this we prepared. And then here you maybe see that air and air parts are acrylic, polyethylene, silicon, PVC, and dentist, that is acrylic and high, and facial prosthetics. Nowadays is prosthetics that is most important nowadays is because all nowadays like a human leg movement, they are preparing some prosthetic legs. I approached my relative also for that. They be given some material. You should check with the human how it is. He told that it is not blindly we cannot able to that. You should get some central government permission. How to those things were you. And then heart components are polyester and silicon PVC. Because I hope you all know that initially ball replacements are made under that metal only. For my mother, 2019 they changed as a one of the right artery valve due to the valve shrinkages. So they told that metal compared to the metal, polymer is more costly. We spent nearly 2.5 lakhs for 2.35 centimeter, 2.35 centimeter length of valves to put for that more, that is behave like our wall, a natural wall like that. And then it is more comfortable to control the your heartbeat, that is conveyed by doctor. So don't go with the metal. Nowadays is all are thinking about that polymer based, that is polymer based applications in other also. And then heart pacemaker, polyethylenes are using. Now all are preparing. Initially one of the most complicated business, but all the peoples are working with making of liver and lungs, and then kidney. Because if it is naturally behave, then the medical field is totally changed, that will give the most impact. So what biopolymer will give, all those things parts are given by the biopolymers. So for that, what is required is, as a point of me is, so we should require facilities. That is most important nowadays. So what is a biopolymers is, first one is biocompatible, affordable, and durable, effective, and then compactable and compostably. It want to be non-toxic, eco-friendly, renewable. So those things are there in this area. And then metal and alloys. After that, metal and alloys, we have what is the stainless steel wheel for fracture friction and stents, surgical instruments. So initially, that is biometals. So that is bones and joints replacement, and bone joint replacement. titanium will give bone place and stents and orthodontic, and gold alloys dental. I hope everyone see that the golden alloys in the dental tooth, and silver products for antibacterial agents. So most of the things are in medical field will emerging with a biometals and alloys, and as well as bio, and then ceramics, aluminum, joint in dental and implants, and after that zirconiums and calcium phosphates for the bone replacement. So for that also we proposed something, but it is in the scratch level. We are improving that one. Bioactive glasses. Bioactive glasses not only for that bone replacement. One of my professors are approached that automatically, because everywhere we are using automobiles, so without of wiping, how automatically cleaning, for that we approach like lotus properties behavior, but it is in progress of uh, in scratch level. So it should be improved because it's technically needs some bio tissue biocompatibility, and then how it will give sensor properties. We up to contact of angle we tried, but still more it's required. And then medical additive manufacturing. So it will go with nowadays the jaws are very different, because most of the accidents or anything, initially it's very tough to make a product, but we speak with more medical people like doctors. They are saying that if you are giving on based on the x-ray or something, we can able to take down the jar sizes. Based on that we can able to print. So that is a 2D cross section area. After that image processing and then visual modes we can able to print. And this is the data processing software. We have different type of softwares are available in our college itself. So by using of CAD and other things, and then simulation, computer modeling. After that, design validation is most important. After the physical of 3D model, we can go with FA. This is the last image is FA. That is also most important. So before going to the FA, mesh itself play the major role. So that also they are analyzing nowadays. So some of the medical image processing software are available. So these are the softwares are available. You may be tried with the softwares. I tried some of the things. So by using of 3D slicer, and I highlighted something SEG 3D that are all free accessible. But if you are collaborating with the people, you will get 1 month, or if you are putting something, our ID card, other things, means you get some 1 year licenses. Because for everything, what is that is physical model is important. What is the physical problem is? Physical model is visualization of problem. No physical feel of the area of interest. Because when you say about something, they will not understand. You see here, the jaws are in third image. So here jaws are will give this is and all can able to give the feel about it. So for a surgical term, communication and then educate the patient. So assist the surgeons with the diagnosis and then surgical planning. For a rehearsal or simulation of surgery, it is most important. For a creation of customized prosthetics, anyone try to do some work means you better try for prosthetics. That is most important. So most emerging area, if you are, what is the shortest way to make the textures are very lightest material, that is most important. For accurate placement of implants, so this is a physical model is play the major role in this area. So general procedure is, first of all, we go with image acquisition. So you in future maybe major role play by the AI nowadays is no need of creating of images. Already one of the software is implemented for the modeling. If you are prompt well, that prompt, and based on the prompt it will give the what are the output diagram you need to print. Okay, next one is CAD modeling. After the image it come to the CAD modeling to the 3D printing, and then post processing. This is general things. You maybe see here CD to CRI, and then CD 3D restructured, and then direct slicing of CAD models. After the direct slicing, it will come to the rapid prototyping like stereolithography or other methods or bone tissue, and then models of clinical of medical applications. Next, what are the in medical surgical planning, and then it will go with the implants, and then ortho. This is a very emerging area, that is Michelin Tech. So you maybe see here, and then they are preparing some hand grips. If we having initially, we will put some. When colloquially we say that நம்பூர் பக்கம் புத்தூர் கட்டு போடுற மாதிரி புத்தூர் கட்டுலாம் தேவையில்லை இனிமேல். It will based on that, it will give a very good prominent support and give the strength to without of causing any damages, and surgical planning of software requires of FDA clearance, that is most important here. Next, so where majorly applies, massive tumors are removed, 3D printing in for a covers, you maybe see here covers are there. Then aesthetic solutions when you need some aesthetic looks, and dental prosthetics, tool aligners, and then hearing aids also they are preparing more, and then high prosthetics. So you know that the hip, that you should use of hip prosthetics also. Initially it's not there, but nowadays is like our hip it will preparing, and then it is printed by our 3D printing purposes. So there another one is prosthetic hand. So one of the Dyson award winner of prosthetic hand, you will see that magical humps. Whether I hope that you know this story, last one. So Hamas Duli print his own dental alignment due to the college something criticisms and bully. He measured, and then he prepared his own tooth, and then he printed. It's famous during the 2 years or 3 years before, and it is printed. And then applications of AI medicines. So even though orthopedic suggests total hip replacement is possible, and then dental implants, corneoplasty, and maxillofacial surgery. Maxillofacial surgery is nowadays is doctors are integrated with or collaborated with the mechanical peoples or materialist people to do houting. And then IoT, biomedical devices, biosensors. After that, MEMS also nowadays is most important, and microfluidic devices for microprocess and bioseparation, and augment tangible molecular, this type of researches and educations. So after this, waste management. So I spoke about digital too. Now we are having about waste. So India wide will be number one in 2050. CO2 is equivalent. You can see that 2.6 billion tons in 2050. So think about novel waste management is most important. You see here, the most popular countries in 1950, India is standing on second one, populations. Okay, here if you come to the 2024, India is number one, and still future populous countries taken care by 2050 also still more. In China also will not beat us, so we will stand on in populated area. So after that, you see that more attention is required to give the environmental care is most important. Preparing of novel materials or preparing of something is not important. Socially, it want to give some impact. So for this only, I'm giving this waste management. So per capita, 0.2 to 0.6 kgs are waste management is in this. India generate nearly 62 million tons of waste from the waste of each year. So 43 million tons, nearly 70% are collected. Understand that? And then 12 million tons are treated, and 31 million tons are dumped. Waste dumping and open burning are the principal methods in India. That is one of the worst method we are following still. In other modern countries or developing countries they are changing the process of method into different cases. Like they are preparing some bricks, they are preparing something in water coastal areas, and then they are totally banned that plastics oriented, that is if you are not able to recycle the plastic, they are totally banned that plastics. So those are things are using. And if you take about the composition of waste, in South Asia. Okay, so rubber and leather is very well less. You see that food and green will taken care of 57%. 57% food and green only. And remaining things plastics, if you see that pink color, that is called as 8% are plastics. Paper and cardboards are sometimes replaceable. So here we are using that opened up. So possible of how to composition of waste will come, how to collect, possibility of recycle, how to reduce, where to reuse, how to process. Those things are important. So whatever material, what can do, I now. So you should take about the materials to consider. I hope everyone know this diagram. So this diagram will give that biofactors and compactability factors. What light, if you're having heavy and lower strength, what will give? Lightweight and high strength, what will play? So based on that, you should prepare the materials and then go with this. So footwear utilization. Don't waste the food, because based on the food, how they are converting into some useful of research work. I hope one of that Itish Sharma. So he published a paper in effect of particle size and thermal mechanical behavior of epoxy reinforced with a food waste fillers. So it is published in Institution of Mechanical Engineering SEA paper with a minimum of impact factors, and then coconut fruit, how they are making into crust and then powder. So like this, all the eatables nowadays. I also worked with in conch shell, and then some of the natural fillers are working. So these are the food waste utilizations we can able to convert into some useful products, useful some structure, not using for a dynamic applications, but we are using in some structural applications. Another one is organic fillers, fibers and fillers utilizations. You maybe see that here one of the fillers root waste of novel cellulose fiber for a lightweight polymer composite applications. In polymer composite, they are by the waste material they are preparing, and then they made as one composites and prepared, and then they published work in that area. So if you are having any idea in cellulose, that is that will play the major role in bio polymers. Next, another one is agro waste. One of the one of my friend, Dr. Indran Swamilingam, published a paper in that industry waste. So isolation and characterization of microcrystalline cellulose, and then agro waste, and it is published in SEA. More than 7 impact factor. They prepared some products in that they are using some cell cultures, and then they published some journal, and then it is patent also. And another one is effect of banana is nowadays banana fiber is now more number of products are making in that banana fiber. They are making customized products also. So and then pineapple, and then coir flyers filled with hybrid filler epoxy based. It is published in 2021 and composition. So pellets are making into so many of applications in that area. Next, another one is agro waste. Maybe see this banyan trees. So that we take as a borous fiber, and then they change it into renovate. This and all, for this and all is not need of some sophisticated or technical equipment. Some basic things are needed. So based on that, we convert into filament or polymer. We do some work in that area also. And another one is this also published in International Journal of Biological Macromolecules. So in that chicken feather, everyone nowadays is all the areas they are taking out chicken feather to put some other things, and it give most polluted dirty smell in so many of areas. So here our professor, our friend Indran Swamilingam is prepared something, and then they treated, and then they approached, and then they prepared some bioepoxy resin based on biocomposites, and it is published in International Journal of Biochemicals. Next one is that is ceramic waste utilization. So ceramics are because it is uncorroded material. Everyone know that So that waste marble dust filled with fiber reinforced composites and thermomechanical or erosion behavior properties, maybe we can able to utilize for that mechanical properties by using of resin transfer molding itself. RTM itself it is used there, and then we can able to crush, and then based on that we'll use. Next, paper cup utilization. So preparation of bio eco based cellulose nanomaterial for use to disposal of paper cups to the critic and hydrolysis. Like, so this type of the things we can able to do application oriented things we can able to. This is a carbohydrate polymer, also one of the most reputed journal in Elsevier. Next one is cupboard utilization. You see here, and development of new eco-friendly material, that is sustainable materials in that area, gypsum reinforced, and then mixture of cork fiber, cardboard washed, and then building of thermo insulations. Next, oil waste. So we also trying that one to preparing something in area of Ennur power plant. We are taking some fly ash and then making something. So like this industry, oil industry waste utilization. So isolation and catalyzation of novel microcellulose from sedum and agro-industrial reducible waste, oil cake. They prepared some biomaterials in that area. They utilized in some area. Next, same thing, a seam novel seam oil cake biomasses. That is, they prepared a derived cellulose and microfibrillous in basalt for a hybrid polymer composites for lightweight applications in that cases. So this is role of 3D printing for analyzing for dialysis patient. They prepared this whole systems. Instead of this, they prepared some dialysis, and this will give the better comfortability for the doctor. Initially, it will be like this. So now it is prepared on this dialysis systems on this area. So waste biofilament, what is we can able to use cocoa shell waste, and other waste we can able to use for the bio waste we can able to make as a filament. So these are the clip itself play the major role. It is patent also. That will where we want to stop, how it want to flow. So this is one of my friend is prepared this one and published pattern, and then for a dialysis clamp will alone. So next, a blue dialysis for tube closer for the urine pack and other things. It will give some impact. So for that, they prepare something into tube, and then that tube will be arrest the fluid in such areas that then they'll give. Next, this is urinary catheter. You see here, by using of like rack and pinion mechanism, they are using as a urinary catheter to arrest or to next. So what can I suggest is change of material properties, another one research cap, reducing of particle size, coupling agent, modern extraction techniques, efficient process of scale up, source of free contaminations and reduce transportations, waste fillers in PMCs, utilization of waste as a commercial goods. So these are the tailored material. What I can summary is tailored material properties, enhancement of strength to weight ratios, waste-based polymer composites can offer, and then waste of agriculture, urban, industrial activities becoming value-added materials. We should search the answer of recycle every kind, and then manufacturing is left over. There are more number of investigations are required in safety life cycle. Next, as a self-financing engineering college, we are not having that much of funding. Don't stick on that we will get funding or not. So far, nearly 6 years I'm applying. I am not getting any funding, but we are never stopped to apply the funding. These are the funding opportunities in medical additive manufacturing, or otherwise mechanically you can able to apply SERB, DST, and then DBT. This DBT will give something forward, then and then MHRD giving more funding nowadays. After that, CSR, and then BIARC, and after that Indian National Academy of Engineering. Then after that in that is Ministry of Electronics and Information Technology. Those who are having idea to work in National Center for Additive Manufacturing, you go with the NCAM. NCAM giving some funding. Last time also we applied that, but unfortunately they given to only in one proposal to the uh, SIPPET only the granted, but fortunately you will get an additive manufacturing of society in India. So Andhra Pradesh Medzone on this R&D centers. Other than that, incredible private sector, incredible. You may be touch with other core companies. Nowadays, if you going to propose any proposal, if you collaborated with the industry, you will get fruitful outcome. That is a major because recently our civil professor got 45 lakhs funding from the uh, DST. So they are getting collaborated with industry. Will get major what is that probability is more if you have novelty. I'm not saying that without novelty they will give industry. With the industry, if you're doing with any proposal, if you're having any novelty with some work, if you collaborate with the industry, the chances of getting funding is more. So after that, before lab with the IIT Hyderabad and then IIT Kanpur, BT medical devices, if you do that, BT they are doing. So only one suggestion is if you're going to do any R&D works or going to do any research work, don't spend your own money. Apply for so many of proposals. Initially, that only we are doing that one based on that government, some getting some fund from them, initial amount, then only we are getting some fund from them. So once again, thanks for the opportunity. I thank the VTMT management principal, head of the department, and coordinator and co-coordinator. Special thanks to Muthukumar sir for approaching and given opportunity for that. Thank you, sir.
Sir, very wonderful session, sir. I think everyone enjoyed your session. Not only faculty members, researchers, funding agency seeking people. I think you have given a whole sum of what is going to be this material. Frontiers is going to be very justified your theme, your topic, whatever you have taken into account. You have also completed your topics well within the time. I think I could see how many efforts you have taken to collect all those information. It will be useful for many more sessions. What you will deliver for the future expert lectures, because everything is consolidated. If you are talking for only 5-6 slides, also you can talk for hours. Also, that much content you have put, and it's a very tremendous effort, sir. Out of these sessions, previous sessions, I have not seen so many content put into one thing, because you've given all efforts to justify to your topic taken. So I should sincerely thank your efforts, sir.
Thank you, sir. Thank you.
So we are also having another session, sir, in the 12 o'clock. We are sorry to not wish everyone in the prayer session prior to the starting of the session. Today is a Christmas Eve. Even though people are at home celebrating at their own facilities this holiday, number of people have joined and sticked on to the timing. Everyone joined and given their efforts. If any questions are there, you can direct through me. I think we are crossing the time. If any questions are there, you could have put in the chat box also. Sir, whatever explanation, there is a question from our faculty, sir. Shall I read from the chat box now?
Yes, sir.
Yes, sir. He's asking like, how do 3D printing parameters, the layer height, infill density, raster angle, printing speed, nozzle temperature, these parameters affect mechanical properties as predicted by AI, artificial intelligence, sir?
So definitely, and thanks for that. Definitely, it affect the mechanical properties. Because we written these two papers in that specifically in the printing angle itself. So, but AI will predict. AI is nothing, sir. AI is nothing but it is collection of all the data, sir. So when you having more data, then only it will give a better accuracy. But still nowadays as mechanical AI papers are working with only an a mechanical categorization and the layers preparations and other things, because we will not get more data. And fortunately I'm doing artificial intelligence in data science, MTech, in addition to that. So we are doing some what is that, protections. In that we need of nearly 3000 or 5000 data sets, then only we can reach minimum of 70 percentage or 75 percentage accuracy level. So when we having combined with more number of algorithm, when we having combined with more type of hybrid algorithm, even though now we are speaking about hybrid composite, like this AI algorithm is also nowadays is combined with a hybrid model. So we approached with a hybrid model of CNN with supervised learning. For that we are working in that supervised learning, that is supervised SVM, we called as support vector machine. Along with the CNN and then support vector machine, we get of accuracy of around 86 percentage. So when you have a more data, AI will give predicted. AI will give with the minimum prediction data also, but accuracy level is very less. That is a major factor. Which machine learning can suitable for studying mechanical categorization? Sir, there is no any specific machine learning algorithms for preparing of suitable. All the algorithm will uh, give the prediction of or give the suitable things. But in what way it give accuracy? That we cannot able to say. The based on that we predict that CNN will give the major accuracies. So we go with CNN. And then now all are thinking about some initially we have basic of there is supervised learning and then unsupervised learning, sir. Where these things are called as supervised learning only, we go with the supervised learning. So when you go with the supervised learning, there are three random forest and then decision tree, and after that SVM, support vector. So mostly nowadays is all are thinking about the AI and how artificial neural network we can able to predict the mechanical categorization. So for that directly nowadays is they are giving coding and everything is in available in Collab, or so many of the data transfer applications are available. If you want to predict any data sets in Collab itself or Gaggle is there. Two things are Collab or Gaggle itself. You get a data set. From the data set you download and then you just check. After that you find you get some data. That data you put and then you find out the prediction values. That is possible. How biomaterials are boosting the seed your growth. Sir, we are taking some biomaterials boosting is from the natural material itself. Actually, our chemistry professor is Sudhagar. So he doing some agro waste like this he prepared. So by using of that agro waste, we prepared some tissue like paper like structure. I will not know that what is exactly that chemical name. So we given some tissue something, and they prepared a novel biodegradable, eco-friendly, absorbent polymer for better yield in plants and as well as agriculture, sir. So that will give the better output, sir. You maybe the students prepared that uh, that uh, that product. What is the product is they we prepared a very novel biodegradable, eco-friendly, super absorbent polymer for better yield in plant and as well as agricultural crops. So for that, they are using super absorbent polymer from the moisture and the natural resource itself. They are taking some agriculture and it is published. I will show some. We taken from wheat starch, sir. After the wheat starch, it is implemented to the some vanillin something and then carboxyl methyl cellulose, and then after that it will peel and then it will substitute in that. The growth of the water absorption is day by day more. So that water absorption test also we tried with that one. So after that 11th day, up to 11th day we tested. it will come to the give the water absorption capacity is more. So more number of publications are there in that area. So if you go with water absorbent, that will give more. Sir. You just try with agro waste or bio super absorbent polymer, then you get a lot of work nowadays. Be published only in Scopus, but more number of work in that areas. Thank you.
Sir, I should be really thanking the participants also. They have listened to this uh, wholesome of material stock. I don't think there is no more questions, sir. I should properly give you a rest after this long talk.
No, thank
I
you.
hope our association is continuing in terms of research and guidance. And we look forward for more such meetings, sir. Thank you.
Thank you.
Thank you very much, sir.
Thank you, sir. Thank you.
Thank you, sir. Audience, the guest will leave, but you be